So now let's see one type of operational amplifier. We see the integrator. How do we go about solving an integrator? Okay, so this is what we're going to see now. Okay, we need to get the transfer function. We're going to find the transfer function. So we need to find the transfer function, and the formula for the transfer function, it's equal to, so the transfer function is equal to the output over the input. Okay, so in our situation we need to find this, the output over the input. Okay, and this is where we have our input, and this is where we have our output. Okay, and we have one formula that we always use here. So let me just define what we have here. This is the impedance 1, and this one is the impedance 2. Okay, if I have to solve for this integrator, okay, I'm going to go about solving it. So now the way that you can go about this, the input over the output. Okay, so since we're working with the non-inverting input, remember that we said we have we're working with the inverting input. You see, this is the inverting input. So the equation is gonna be like this. Okay, this is how I'm going to write it with the inverting input. So we're going to put minus for the inverting input, and then we're going to write the equation as this. Let me just write it correctly so that you can see this is equal. Okay, it's gonna be Z2 over Z1. So for the transfer function, the output over the input. Okay, so this is what we need to solve. Okay, and there's one thing that you need to know before we continue. So if you recall, this is the S domain formulas. Okay, so we're going to use them directly into these equations. Okay, and we know that Z1, inside Z1 we have a resistor. Okay, and into Z2 we have a capacitor. So what we're going to get here, so for the transfer function, we're going to have something let me just place it here. So the output over the input equal, okay, and we're going to replace the value of Z2 and Z1. Okay, so we said Z2, we got a capacitor inside here. So the formula for the capacitor, where is it? This is the formula for the capacitor. Okay, then there is an easy way for us to write this equation, not to make the mess up things. So I'm going first to arrange the equation. So I'm going just to write what we got, what we had before, so that you can see, you can clearly see where we're going with this. Okay, let me just put negative there, the way it was. I'm allowed to move Z2 outside. Okay, so it's gonna be 1 over Z1. If you can see, these are just mathematical equation, so you can take out, you can move it in front, or maybe just write it in this way. Okay, this is the same as what we had the other side. Now I'm going to replace the value of Z1 and Z2. Okay, so we're going to have something like this: the first bracket times the second bracket. Okay, so what is Z2? And as I said, Z2, it's actually this one there. So I'm going just to highlight it. That this is the our Z2. Okay, so this is Z2. So we're going to replace the value of C. This is the formula of VC. So we're going to replace it into Z2. So we're gonna take this formula and replace it into Z2 because Z2 is constituted of C, and the voltage across C is Vs. So we're going to replace VC, sorry. We're going to replace with VC. Okay, that's what we're going to replace there in that for Z2. Okay, so what we're going to get there, we're gonna get something like this. Okay, if we replace Z2, you will get something like this. We're gonna have the same equation that you see on this side. Let me just make some room. Okay, so we're going to have to write it in this way. Okay, so this one's gonna sit right there. This is Z2. Now we need to replace Z1. So since Z1, it's actually constituted with from a resistor. If you check here, this is Z1, and the value in S domain of Z1, VR1. So we're going to replace with VR. So this is VR that we're going to replace here with what you see inside here. Okay, so we're going to get something. We're going to get what you see here. Okay, this is what you're going to see inside there. So what I'm gonna do, I will just move this one away and put this one inside there. Okay, in this way, this is what we're going to get. Okay, and this is what we get for the transfer function, and from there we can now solve. We can now solve. After that, we will solve for V out. If we have to get the voltage output. So let me just write it correctly. We're gonna have V in equal negative, okay, negative I S, okay, C S times I S R. You can even see these two will cancel out. These two will cancel out. So we're going to remain only with 1 CSR. Okay. And since he has to write it correctly, it's gonna be CRS. Okay, in S domain. So when you get that, you can now solve for the for V in or V out when you get to that equation. So you have the option to solve for. Okay, this is now the final answer of our transfer function. Okay, but if you want to solve to keep, maybe you just need V out there. So if you have to write down the equation of V out, you will get something like this. So we know that the transfer function equal to, since we're working with S domain, I'm going just to write there S. So just to show that we're working with S domain. So that's why I'm putting S there, just to show we're working with S domain. Even this too, it's in S domain, but let me just leave it the way it is. Okay. So if I have to write down the equation of V out will be equal to, if I multiply V in to both sides, then I'm going to remain with V out equal to V in CRS. And if you just let me just give you a simple, just move this one at the top of the second fraction. In mathematics, you can do that. So you just move it in to the top of the second fraction. This is if you have to solve for V out. Okay, and then V in is gonna be just the same principle. And then if you have to write this equation in times domain, you're just gonna take the inverse Laplace. If you apply the inverse Laplace to this equation, okay, then you're gonna get the inverse Laplace. So this one is gonna help you to move from Laplace from S domain to T domain. So you will get something like this: VO of T in times domain, it will be equal to the equation that you see there. So actually it's gonna be the inverse Laplace. Okay, let me just write it correctly. The inverse Laplace so you're gonna get the inverse Laplace of 1 over S, and then you're gonna have V in and so on. So this is just to give you an idea. I'm not gonna go there for now. I'm going just to write a simple equation of how you, if you want to move from the times domain of this equation, what you can do for you to get the times domain of this equation, you can solve it from this transfer function. Okay, so I'm going just to leave it like this for now. So this is how you go about solving for an inverter. Okay, so if you have to solve for the inverter, this is how you go to solve, not invert the integrator. If you go for to solve for the integrator, this is how you go, and this is how you do you solve this question. Okay, so I'm just trying to give you an idea of how we got these formulas.